to get a line. It's called slope-intercept form. So yesterday we talked about slope. We're going to talk today about intercept. Intercept means to cross, so we'll be talking about the y-intercept, which means where it crosses the y-axis. But we'll go over that again. First of all, here's the form. Here's what this looks like. The standard way to have slope-intercept form is to have the y all by itself, so that's important, getting y by itself. If it's already by itself, then it's in slope-intercept form. If it's not, then you have to get the y by itself. So, get y by itself. And the m and the b will be replaced with numbers. Right now those are just placeholders. M will be the slope. So we'll replace it with the number that we get by finding the slope. And B will be a number that is the y-intercept, which means where the line crosses the y-axis, where it intercepts or crosses the y-axis. X and y will stay as variables. They will stay x and y in the final form. The idea with this, if you think of all the different points that we've been finding that go on a line, is that you could take any one of those points and take its x and y and plug it in, and it would work. So we keep x and y to show any xy pair on this line, we could plug those values in right here to these spots. So the x and y will stay as variables, and that's in the final form. We might need to put something into slope-intercept form. Again, the slope we want to replace with a number, and the b we will replace with a number that is the y-intercept, the spot on the y-axis where the line crosses. So first of all, nice and easy, what if it's already in that form? If I gave you this equation and I said, what's the slope? The y is already by itself. Now, what's important, notice, and I pointed this out on last night's homework, is that the slope is always the number that's multiplied by x. In this case, it's in the right order where that x comes first, but it could be switched around. Maybe they put the 2 first. The slope is always the number that's being multiplied by the x. Always the x. So what's my slope in this equation? Izzy? 3/5. And my y-intercept, I'm going to abbreviate intercept there. What's my y-intercept according to this? Daniel Q?
2.
Yeah, 2. And in this case, we can just write 2 because it's positive. If it were negative, that would mean it would cross at the negative part of the y-axis. Now, I do need to come around with some little graph papers because we are going to practice graphing using this method. The good news is this means we don't have to make a chart. If you want to make a chart, you can. But this method saves you a lot of work if you can do it this way without making a mistake. So, we write a little graph square. If you want to wait to paste it till we've done the work on it, that should be fine. I have just enough. 3, 5. Okay, I'll use this one. Okay, let me show you how to graph using the slope-intercept form. So first of all, if it's already got the y by itself, that's good news. We're going to graph a different one. Try to not be too wavy with it. Mine went a little curvy there. Give yourself an x and y axis on your little square graph paper. And I think what we're going to try to do is, I'm going to use color here to try to do 2 different problems on this same grid so that we don't have to take up too much space with our graph square. So the first one I'm going to do is already in slope-intercept form. We're going to first graph, now this is to do it without a chart, y equals negative 3/4 x plus 2. Now, off to the side, I'm going to write some instructions to graph using slope-intercept form. There's only 2 steps to graph using slope-intercept form. 1, plot a point at the y-intercept. Now again, the y-intercept means where the line is going to cross the y-axis. So whatever that number is, and in this case, just like the previous example, in this case it's positive 2. If it were negative 2, we'd go down to the negative part on the y-axis. We'd go to negative 2. But since it's positive 2, here's positive 2 on the y-axis. So I plot it. Now I don't even have both the coordinates. I just know that the y-intercept is 2. So I go on the y-axis and I plot 2. That's my first point. Right now, this is all we know. Without making a chart, the only thing we have as a point so far is this dot right here at 2 on the y-axis. Count from the y-intercept using the slope, and I'm going to put rise over run. So we have to start. The only point that we know for certain right now is this y-intercept. So we start with the y-intercept. From that point, we are going to count off. Rise, remember, means up and down. Run means horizontal. It's always rise over run. Now in this example that I'm doing, let me just show you. It said negative 3/4 as the slope. Let's scoot it up a little bit here. Let's see if I can get this all on the screen. So notice it's got the negative right out front. I know that's the slope because it's multiplied by the x, right? That's where the m would go in the formula. Negative 3/4. To count this off, you're going to want to move your negative either to the numerator or to the denominator. It doesn't matter. But having it out front doesn't really work. Now I'm going to show you one of each. I'll show you counting off, step 2, counting from the y-intercept. I'll show you first using where I put the negative in the numerator, and then I'll show you that it could go in the denominator and it would still work. So here's what I mean by counting off. It's rise over run. Rise means vertical or up and down chain. So from this point, if I use this one first, the negative 3/4, this says, again, not starting at 0, starting at my y-intercept. This says a rise, up and down, a rise of negative 3. Well, negative is down, 1, 2, 3. A run of positive 4, 1, 2, 3, 4. Again, from this point, I did a rise, top number of negative 3, a run of positive 4. Now, let me do the second one. What if instead of having the negative go up in the numerator, what if I put it in the denominator? Again, starting from my y-intercept. I can't start at 0. This line might not go through 0. In fact, this one does not. This one says a rise of positive 3, which means I'm going to go up 1, 2, 3, but then the run is a negative 4, so after I go up positive 3, I'm going to go horizontally 1, 2, 3, 4, and if you see my dots line up, making a straight line. So with a negative, you can have the negative sign either in the numerator or the denominator. You just have to be careful as you count your rise and your run. Any questions on what I did there, how I got from one point to the other? The important thing, remember, rise is the top number. That's up and down, right? So negative 3 or positive 3. Run, the bottom number, horizontal, across the x-axis, positive or negative direction. Okay, let's do one more. I would like to maybe come back. I'm going to do it on this same grid in a different color. But first, I want to do one more. And here's going to be the difference on this one. This one is not in slope-intercept form. Today you're going to be graphing using slope-intercept form, meaning you're not making a chart. I want you to try this method of starting with the y-intercept, right? Plot that point and then counting off. So this one is not in slope-intercept form. What do I need to do? What do I need to make it look like to have it be slope-intercept form? Look at step 1 from up at the top. Rebecca.
Has a y.
Get the y by itself. I'm going to leave the variable, the y, by itself. I'm going to move over this 2x by subtracting it from both sides. Negative 5y equals. Now, I'm going to put my negative 2x first, and then plus or positive 10, because remember in slope-intercept form, often the x comes first. Now, one final thing you have to be careful of here. My final step is to divide by negative 5, and here's where I need you to be careful. We need to divide every piece by negative 5. Every piece. We haven't done this kind of equation before with 2 different variables, an x and a y. We've only had 1 variable so far, so this is a little different. And when you divide that final step, you have to divide all the pieces. Now, negative 5 divided by negative 5, I get my y by itself. Negative 2 over 5. Okay, guys, there's my slope. Negative 2 over negative 5. Now, let's think about simplifying that. A negative divided by a negative makes a positive. You can keep them as both negative, but we could also just say, that's my slope. I'm multiplying the 2/5 times x. And now, finally, positive divided by negative makes a negative 2. So again, you have to divide all the pieces by that final number, and then be careful with your signs. Go carefully. If you get the sign wrong, your graph will be wrong. We're going to start with the y-intercept. Now that I've got it in slope-intercept form with the y by itself, now I'm going to come back and I'm going to graph on my same grid, and this time I'm going to do it in orange. Okay, if you think you need a different square, you'll have to wait because I don't have any cut. Sorry. So maybe pull out a pencil or a different colored pen for this one. We're going to start with negative 2. Again, step 1 is always plot the y-intercept. Since this is a negative, I come down to the negative 2 on the y-axis. And my slope, now that I've got it all the y by itself, my slope is 2/5. That's from the y-intercept. I'm going to count a rise of positive 2, so that's up 2, a run of positive 5. Now, I'm about to go off my little paper. If I tried to get a third point, up 2 over 5, I don't have room on mine. Remember that this started out right here, negative 2 over negative 5. What if I do them both negative? I start again from my y-intercept and I go a rise of negative 2 and a run of negative 1, 2, 3, 4, 5. If I look, hey, that's lined up, and I was able to fit it on the grid without having to go over. Now that's just because our square is so small, but you could do either version, the positive or the negative version. Don't forget at the end, we connect our lines, our dots into a straight line. So I'm going to give you guys graph paper. Today your challenge is to A, turn the equation into slope-intercept form if it's not already there. Once it's there, to try to graph using just the y-intercept and the slope. Questions, Vincent?
Does it always have to have 3 points?
I'm going to ask that you always do 3 to make sure that you're doing it right. If you only have 2, you might make a mistake and not know it. If you have 3, you're more likely to catch a mistake. Not always, but more likely. Okay, any questions on what I did on that last one? Alrighty.